Okay, next we're gonna go to the actual configuration, a basic configuration for the CCNA level exam of zone-based policy firewall. If you look at the, we also had a CCNA bootcamp, which is already in the AAP section. We've done in the bootcamp a couple of more examples, and we've done some more advanced examples of zone-based policy firewall with both pass, inspect, and direction, both one way and two ways. So you're gonna see in there much more examples to have a better understanding, and also to be able to better implement a zone-based policy firewall on the iOS devices. Now from the configuration point of view, we have to follow up on those blocks. So it's very simple. We define the zones, then we configure a layer 4 of type inspect class map and match on the traffic which we want to control to the firewall, and then we configure the layer 4 inspect type policy map. We bind, attach the class map, and then for each class map, because we can configure multiple of them, we define a file of action which can be pass, inspect, or drop. Then we find the zone pair. We specify the firewall inspection direction, what is the source zone, what is the destination zone, and we bind the policy map to tell the router how to control traffic flowing from that source zone to the destination zone, what action to take for which traffic, which that's being defined in the policy map. And of course, the last step is going to be to attach interfaces to the security zones. Verification-wise, you can verify the security zones, which security zones have been defined, which show policy firewall config zone. Now, this show policy firewall command was added sometime in 12 something code, but the zone-based policy firewall, let's say, feature was on the iOS devices from a long time ago, from I think it was 12.3 code or something. So the old commands were a bit different. It was something like show zone security, show zone something. You should no longer use those commands because you can first of all, it's going to be probably obsolete, and second of all, you cannot see everything with the show zone commands as you can see with the show policy firewall commands. So some things will not going to be available for you to verify using the show zone commands. So verify the zones, show policy firewall config zone, and again the command makes sense since we're here, because I haven't done this for a couple of videos now. Always look at the command, right? So the zone-based policy firewall, so it's a policy firewall. So the command in here makes sense. Show me the policy firewall configuration of zones. So the command is self-explanatory. So again, once we understand the scope of a technology, you understand the building blocks of that technology, then you go configure them, and you also configure and verify them. Look at the commands, both configuration wise and verification wise, because most of them make sense, and if they make sense, you don't have to memorize them. Once you have done the technology, you've understood how it works, what is the scope, you have done a couple of times to see it with your own eyes, to practice it, you don't have to memorize the commands. So again, how good is that command? Show me the policy firewall configuration, show me and I want to see the zones. If I want to verify the class maps, show me the policy firewall configuration of class maps. Show me the class maps. If you want to verify the policy maps, show policy firewall configuration policy maps. If you want to verify the zone pair, show policy firewall configuration zone pair. And of course, in the end, once you send traffic back and forth to the firewall, and if you have the inspect action configured, which means the router is gonna keep track of the traffic passing through the firewall in the state table, you say show me the policy firewall, so show policy firewall session, and actually you also configure, you specify the zone pair, because of course in the end, because the firewall policy is unidirectional, because as we saw before, and as we're going to see in the implementation side, when you define the zone pair, you tell the source zone and destination zone. So only traffic flowing from that source zone to the destination zone and matched in your configuration is going to be allowed or inspected or dropped by the firewall, because session is unidirectional, and in the end on the router on a live production network you may end up configuring multiple zone pairs back and forth. You may not want to see all of the sessions, you know, from all of the directions. You may want to see only sessions from the state table for a specific zone pair. So you're going to say in there, show the policy firewall sessions, but only from the zone pair and the name of the pair, which is going to be, I don't know, traffic from inside zone to outside zone. Now, configuration-wise, we're going to make router tree. We're going to implement zone-based policy firewall on router tree, which means we have two interfaces. We're going to define two zones. And we're going to, for example, in this use case, we're going to consider that traffic routed, not this, but this one, is going to be like the border of my network, which means traffic routed in that direction. That direction faces the internet, which means, for example, I'm gonna consider that whatever traffic is routable in that direction is gonna be, let's say, the untrusted zone. So I'm gonna bind this interface to a zone named, let's say, untrusted. And traffic flowing in this direction is gonna be the LAN part, the local area network. So all traffic routable in that direction is going to be a member, is going to be the LAN side, and because it's the LAN side, is going to be I'm going to bind this interface in here to the trusted zone. So all traffic routable in that direction is going to be a member of the trusted zone. And then we're going to define a firewall policy flowing in this direction. So from trusted to untrusted. And we're gonna, for example, match on telnet and SSH and choose to inspect that traffic. Which means that only telnet and SSH traffic is gonna flow in the direction of trusted to untrusted. And because I'm gonna inspect the traffic, it means that return traffic is gonna be allowed by the firewall. And what this means is that, for example, in that direction, so in this direction, trusted to untrusted, all other traffic like ICMP or HTTP is going to be dropped. It's going to match on the default class map with a drop action. And likewise, all traffic flowing in this direction, which means from the untrusted to trusted, so traffic initiated in that direction is going to be dropped, because I'm not going to have a firewall policy defined in that direction. Let's go ahead and do that. So we follow up on the building blocks. We go on router tree, define the zones. Of course, before that, let's make sure that initially traffic can flow in both directions. So let's make sure that traffic can flow both this way and this way, because currently the router just does routing. So let's go on router 1 and ping router 4. So I'm going to ping router 4 in that direction. It should work. And in this direction, I'm going to ping router 1. So let's go on router 1 and ping router 4. So this is going to be like, in the end, is going to be trusted to untrusted. And then on router 4, if we ping router 1, it's going to be untrusted to trusted direction. Of course, it doesn't work because the ASA drops the packet, probably. So let's make sure that this is going to work, because I allowed ping to server A. So let's simulate trusted to untrusted, ping the server A, which is the NAT address of server A, which is this. And this should work. There we go, it does. So also traffic from the untrusted to the trusted interface works, because I pinged from router 4 to server A. That's going to be untrusted to trusted. And of course it works because the router doesn't do any kind of firewall, doesn't have any kind of firewall configured. It just routes the packets back and forth. Let's go on router tree. So first define the zones to begin with. Conf T. So let's say zone security trusted. Again, also the commands makes a lot of sense. I'm defining a zone, a security zone named trusted, and as a security zone named untrusted. Then configure the class map of type inspect, and let's name it trusted to untrusted, CMap trusted to untrusted. And I'm gonna match on, I said protocol telnet, and match on protocol SSH. And that's it. Of course, if you say do show run class map, by default the class map is that it's of type match all, which means actually I'm never going to match with any traffic on this class map, because how could a packet be both telnet and SSH at the same time? Because defining the class map with a match all, it means that all entries, all conditions in the class map have to be met for traffic to match this class map, which of course the packet cannot be both telnet and SSH at the same time. So we have to make sure that we change this around to a match any, and we can change this on the fly. We don't need to remove and reapply the class map. So if you say do show run class map again, it was changed to a match any in there. So step number 2 was done. Step number 3, policy map. Policy map type inspect. Let's name it pmap from policy map underscore from trusted to untrusted. We call in the class map of type inspect, and we say the inspect action. So we can say inspect, which means, as we know, is going to be stateful inspection, which means I'm going to create entries in the state table of the firewall for the match traffic. We can say drop, which means clearly drop the packet. We can say pass, which means stateless, passing the packet. Don't create entries in the state table. The other options are policing service policy, which is going to be policing is exactly what it does, policing. What it means, I'm going to police, do rate policing of the traffic, and this is going to be for doing deep packet inspection. So I'm saying the policy map, I'm calling in the class map of that, and I'm saying for the traffic match in that class map, I want to inspect it. Exit. Next step, to create a zone pair. Zone pair, give it a name ZP trusted to untrusted. Zone pair of type security, of course. And then we say what is the source zone, because again the firewall policy is unidirectional, just like in the case of ASA. We say traffic flows from the source of trusted and destined to the source of untrusted. So this command, what I'm saying is that as traffic flows from trusted zone to untrusted zone, what do I want the router to do with the packets? I want to inspect them as my policy map of type inspect states. I want to not inspect but control traffic flowing from the trusted to the untrusted as my policy map was configured. And the last step is to go and assign the interfaces to the security zones. This is going to be assigned to the untrusted 37 and this to the trusted 13. So interface FA0037, zone member, again the command makes a lot of sense. This interface is going to be a member of the zone named untrusted, and the interface FA0013 is going to be a member of the zone called trusted. Pretty much that's the config. So now let's verify the show policy map, show policy firewall non-map, show policy firewall config zone. Show me the configured zones. And we have defined the trusted zone with one member FA0013 and the untrusted zone with one member FA0037. And because we define a zone pair, it tells me that this interface, the trusted zone, not that interface, the trusted zone is a member of that zone pair. And the untrusted zone is also a member of that zone pair. Then show policy firewall config class map and we have a single class map defined matching on Telnet and SSH, show policy for all config policy map, and we have a policy map defined which traffic matched by my class map SSH and Telnet is going to be inspected. All other traffic is going to match on the class default with an action of drop. And show policy for all config zone pair. We have a zone pair named ZP trusted to untrusted, trusted to untrust. And whatever firewall policy is applied to the zone pair is going to apply in the traffic direction if traffic flows from the source zone of trusted and is routed outbound on the destination zone of untrusted. So what this means is that if the router is going to see traffic flowing between the trusted zone, source from the trusted zone, and destined to the untrusted zone, is going to control that traffic per my policy map. This is my policy map name, which the policy map has my class map configured, which matches on Telnet or SSH traffic. And for that traffic, I'm going to inspect the traffic. All other traffic which doesn't match my configured class map is going to match on the default class map, which has a action of drop. Of course, if we say show policy firewall sessions, we should see no traffic because we have not created any traffic. As I said, you can say for the zone pair of ZP trusted to untrust in case you have multiple zone pairs defined, which is usually what you see in production networks. So now let's confirm that based on my configuration, which I have defined a firewall policy only in this direction, which is trusted zone to untrusted zone. In that direction, only SSH and Telnet should work. Other traffic should be dropped. So let's go and initiate from router 1 to router 4 SSH and Telnet traffic to see if it's going to work. It should work. We should also see that traffic in a state table of router 3. But other traffic like ICMP flowing in that direction, like ICMP, it should be dropped by the firewall policy because it's going to match on a class default with a drop action. So let's go on router 1 and Telnet router 4, CISCO. If we go on router 3 and now we look in the session table, we have an established session only 1, which as you can see it was sourced from router 1, and this then we even have an arrow in there to see the direction. That's very nice of Cisco, right? So the traffic was sourced from router 1. That's the traffic direction and destined to router 4, Telnet. And the session, as we saw also, of course, it's up and running. And it tells you on which class map the traffic has matched. If you just say show policy firewall session, you just see the sessions in there, but you don't know on which zone pair that traffic matched and on which class map of your configured class maps did that traffic match. So the show policy firewall session zone pair, it's a much better configuration verification to use than just show policy firewall session. If we go on router 1, exit, and we SSH, but for SSH to work, I think SSH is not enabled on router 4, show IP SSH. It is not. So let's likewise define a domain name, IP domain name, inelab.local, and domain name. In some codes, it's with a space. In some codes, it's with a dash. Okay. Generate RSA key pair, crypto key, generate RSA, and let's enable SSH version 2, IP SSH version 2. So show IP SSH, now SSH should be enabled. And because SSH requires username password authentication, line VTI 04, login local. And let's define a username in the local database, username Cisco, privilege 15, password Cisco. Now let's go on router 1 and SSH to router 4. SSH minus L, the username Cisco, to router 4 Cisco. And if you look in router 3's state table, we should now see the SSH session in there. So again, the session match on my configure class map as expected. It's established, which means that three handshake has been established back and forth. And again, traffic goes source from router 1 and destined to router 4. It's SSH because it's port 22. We say exit. Now if I try to ping, this should not work because ICMP is going to match on the default class map with a drop action. Not from router, yes, from router 1. So if we go now on router 3, clearly there is no session in the state table, and that session is going to match on ICMP is going to match on the class default in there. That is correct. Because traffic, this class map matches on Telnet and SSH only, and this matches on all other traffic. So all non-Telnet and non-SSH traffic flowing trusted to untrusted is going to be matching the class default with a drop action. If we want to see the logs to get a confirmation, we could go in here and say class default drop log. And now if we ping again, in router 3, we see a log message saying dropping ICMP session from router 1 descend to router 4. The traffic matched on the zone pair trusted to untrusted, but it matched on the class default, which has a drop action. So there you go, traffic was dropped by the router firewall. And of course, in the reverse direction, if we go now, if I try to send some traffic in that direction, which is going to be untrusted to trusted, nothing is going to work because I have not defined any kind of firewall policies in that direction. So before we applied this, before we apply zone-based policy firewall on router 3, we know that router 4 could ping router 4 successfully pinged server A. But now this is not going to work because I don't have a firewall policy defined in this direction. So traffic is going to be dropped. Let's go on router 4 and now say ping, likewise the ping server A. And of course it is not going to work. I don't see a log message in here because I'm not matching any kind of zone pair, because I don't have a zone pair configured. If you would want to see a log message in there, so when traffic doesn't match a zone pair and it's being dropped because there's no firewall policy defined in that direction and the traffic is being blocked, and this is more of an advanced topic, but let's look at it in here. You can go under this parameter map, which I don't have time, it's not in the scope of the CCNA exam to know what that means. And if you say in there log drop packets enable, we should see now also a log message whenever a packet is dropped, because there is no zone pair or firewall policy applied in that direction. So traffic is being dropped. So if we ping again from router 4 going on router 3, sometimes it takes a bit more to see a log message. Let's also try to telnet. By default you don't see all of the log messages because this is to prevent the router from being against the denial of service attack. Like somebody may know that, you know, in the direction of untrusted to trusted, you don't have a firewall policy configured, and if you have logging enabled, then somebody could, send a lot of packets in that direction. And if the router becomes too busy to just log messages on the console in there or on the VTI lines, it may cause a CPU spike. It may cause a CPU overhead. The CPU may blow off, can reach 99, 100%. And when the CPU is above 80 or 90%, unexpected behavior can happen because the router doesn't have any more resources to take care of the real control plane packets like IGPs, BGPs, ARP, and all those kind of things. So that's why these messages are being, let's say, not scaled, are being, what is the proper word? So I don't see a log message for each packet being dropped in the direction of where I don't have a firewall policy defined. But I see some messages saying I'm dropping a UDP packet. Well, this is for something else. Parameter map. Yeah, so in some cases it doesn't necessarily kick in here. Let me do one more thing. Let me disable it and put it back. Log drop packets disable and log drop packets enable. If we don't see it, it may be something different in this code. Let's go again on router 4 and try to initiate the session again. It doesn't seem to show up, but as we saw, that traffic doesn't work, and of course it used to work before. Now it doesn't work because in that direction we don't have a firewall policy defined, and because the firewall policy is unidirectional, just like in the case of ASA, and then in that direction of untrusted to trusted, all traffic is being dropped by default. Like traffic coming from the internet to the LAN is dropped by default, and that is a valid design.